Hello guys, welcome to the channel. In this particular video, I will explain the problem prefix suffix string. So let's get started. Here is the problem statement and it says that given two lists of strings S1 and S2, you have to count the number of strings in S2 which is either a prefix or a suffix of at least one strings of S1. Okay, so an example is given here. Let me explain. We are given two lists and our task is to count the number of strings in this list S2 which is either a prefix or a suffix of at least one string in the S1. Okay, so if you see this cat, then you will find that this cat is a prefix of these two strings, right? So as we have to count the values, our answer is going to increase by 1. Till now we have one strings. Okay, now again if you see this dog, then this dog is a suffix of this particular string. So and our task is to count which is either a prefix or a suffix. Okay, so our count is again going to increase by 1. And what about this rat? This rat is neither a prefix nor a suffix of any of these strings, right? Okay, so I can simply return the count as 2. So you can see here that count 2 is going to be the output. Okay, so now I hope you have understood the problem well. So let's talk about the solution. Okay, so in order to explain the solution, I have taken one example here. And the approach that we are going to use is a trie based approach. Why trie? Because trie is the data structure which is asked by company a lot of time in the interview round. So and even it has very interesting applications in the real world. So this is very important data structure to learn, right? Okay, so what we can do is we can insert all these value in the trie data structure. So a trie is basically used to insert and search for values in optimal manner. How we are going to do this? We have a root here. For now I just want you guys to don't ask about why and how, because I will definitely tell you these things, but for now you can just see what actually we are doing. Okay, so first we will insert the word cats. How to insert? I'll simply insert C here. After that I will insert A. After that I will insert T, and then I will insert S. Okay, now as this word is ended, so I'm going to mark this as the end of word, right? Okay, now I will insert this cats and dog. So you can see that I have already inserted the cats, right? This part I have already inserted. So I'm not going to insert this again. Instead, I'm going to extend this part. CATS, after that I have A, after that N, after that N, after that I have D, then again I have D, O, G, right? Okay, now this is again the end of word. So till now we have inserted two words, which are these. Okay, after that I will insert line. So how to insert line? In order to insert line, I can simply do L I O N. Okay, so this is how we insert values in a trie data structure. Okay, now let's search for this word cats here. So the advantage that we get after inserting the values is we can easily search for any prefix here, right? And you can see that this cats is a prefix of this particular string and this string as well. Okay, so if I search for cat, then I will be able to find the word cats easily. So I can say that this cat is a prefix of at least one word here, right? So I can simply increase my answer by 1. Okay, after that I come to this dog. The problem is I can't search for suffix here, and this dog is a suffix of this string. So the suffix is here, so I can't search for this dog. You can see that I'll start from this D and there is no value D, so it will say that false. There is no any prefix which is having dog value. Okay, so how to handle this problem? In order to handle this problem, we are going to convert the suffix into prefix. Like this is a suffix and this is a suffix. So I can convert this suffix into prefix. What I can do is I can simply reverse these values, right? If I reverse these, then this dog will come to front and the value will become G O D D N A S T A C, right? So you can see that the dog is here but in reverse order, right? So in order to handle this case as well, I need to reverse this value as well. Okay, so I can, if I reverse this dog, then it will become God, and this God is present in this particular string as a prefix, right? Okay, so till now we have figured out one thing, that we can convert the suffix into prefix. In order to uh, in order to implement this, we are going to insert all the values in the trie data structure in the reverse order as well. So if I insert the reverse order of cats, I'll start with the cat. So if I insert in reverse order, then I will have S, T, A and C. This is how I will insert. After that, let me insert this cats and dog in reverse order. So I'll insert G. After that I have O. Then I have again D, D, N, A. Then I have again S, T, A and C, right? So I have inserted these two values as well. Now I need to insert lion in reverse order. So how to insert it? I can simply insert N, O, I and L. This is the whole tree that we need to make, right? If we have made this tree, then we can simply search for these values as prefix. So if I search for this dog as prefix in reverse order, so I will search with the word god, right? And I will be able to find this value. So if I am able to find this value, then I can increase my answer by 1 again, and now my answer will become 2 here. So you can see that how we are solving this problem. This is the approach that we need to follow. Let me write the pseudocode for this. Okay, so let me show you the code, pseudocode even. I have already written the pseudocode here. This is the pseudocode. Since we are given two lists, S1 and S2, so first of all, we are going to insert all the values of S1 in the trie data structure. So it is simply make a TrieNode root, and after that, with the help of this root, we are going to insert the value, and we are going to insert the reverse order of the same value as well. This is what we have figured out in the approach above. Okay, after that, we are going to initialize our answer as 0, and we just need to search for the values in the same order as well as reverse order, and if value is found, then the answer will increase by 1. This is the whole approach that we need to follow, but we are missing something. We are missing two things here. The first is, okay, so the first is this search function, and the second is insert function. Once we have written these two functions, insert and search, then we can simply do one thing. We can submit this approach, right? Okay, so now I'm going to talk about a very important topic, which is trie. Let's see what exactly a trie is. Till now we have just seen the trie in brief. You can see that this is just about a brief, like what exactly a trie do, but how it do this, we have not discussed this thing till now, right? Okay, so let's talk about trie. So what is a trie? A trie is basically a tree based data structure which is used for storing and searching for a specific key from a set. Okay, now using trie, the search complexity can be brought to optimal. Okay, so when we talk about this specific key, then generally this key can be of any data type, but most of the time we take this key as a string value. Okay, so you can think of this key as a string value. Now one more thing is, this trie data structure is also known as a prefix tree. Why? Because it helps in finding the prefix. Now I have written some applications of trie data structures here. Definitely multiple applications are there, but out of all those I have written four main applications. The first is autocomplete feature. So if you frequently use the search engine like Google or Yahoo, then you will find that whenever we write a search query, then Google automatically suggests autocomplete, like for that query, right? If I write LA, then it will suggest me some values like LAB or LAB for science and whatever and so on, right? So this is how is a trie data structure works. Like it makes the use of trie data structure in order to look for all the values that it can complete, right? If you see here, then we have inserted cats, right? So when I type cat, then it will give me two values. First is cats, it will suggest me two values, cats, and the second is cats and dog itself, right? So this is how our search engine works. Now one more thing is writing mails. Writing mails also make the use of autocomplete feature. Okay, so let's move to another application, which is spell checker and autocorrect. So if you use Grammarly or use MS Word, then you will find that there is autocorrect and spell checker feature. So this again is based on the trie data structure. Now let's okay, so this is longest prefix matching, which is used in IP routing table in the concept of networking. So again trie is used here, and the browser also use or make use of trie in order to maintain the history, right? So this is where our trie is used again. Okay, so now this was just a brief about trie data structure. There is a lot to learn, so I'm going to attach an article related to trie in the description box. Let's talk about the structure. So here I have drawn the detailed structure of a trie, how it works. So initially you can see that we have root here, right? And we are going to and we have inserted three values in this root. Okay, the first is ADB, the second is JDB, and the second is ADC. Let's see how we have inserted these. The first of all, we need to insert A, and initially all these values are null, right? So, okay, so I need to insert ADB. So I'll first insert A in the root, and this A is again a TrieNode, right? So if I zoom this in, then I'll find that this is again a TrieNode, and in this TrieNode, now I need to return D. I need to insert D, right? So I'm going to insert D here. Again, this is a TrieNode. So if I zoom this in, then I'll find that this is D node, right? Okay. Now in this D node, I need to insert one more value, which is B. So I've inserted B, and this is the whole B node here. And this for this B node, you can see that the word is ended now, right? And in this point you can see that I have end of word variable which is initially false, which means that the word is not ended yet, but at this point the word is ended, so I can simply return true here. Okay, and the second value is ZAB. So first I'll insert Z. After that this is the Z node, I'll insert A here. Now this is the A node. In this A node I'll insert B, right? And when I insert B, then this is the B node that we have, and for this B node the end of word will become true. Why? Because the word is ended at this point. Fine. Now let's talk about this ADC. For this ADC, we have already inserted A and D, right? After that, I need to insert one more value, C. So in this D node, I have already inserted one value B. So I'm going to insert one more value, which is C. So now I have inserted C, and this is the C node. For this C node, again the end of word is going to be true here. Okay. Now I hope you guys have understood the structure of trie here. So let's talk about the TrieNode structure. So what is TrieNode structure? If you see any of the particular node, then you will find that every node is following the same structure like this. This is the structure of root. What we have here, I'm going to write the structure here. So it will be a TrieNode. You can implement this by using a class or struct keyword. You can use any of the encapsulation unit here. Okay, so how to implement this? First of all, I have a boolean variable which is either true or false, which will tell me end of word. So I'll make bool end of word, right? So end of word here. So this is basically going to tell me whether the word is ended or not. After that, I have an array here. The size of this array is 26. Why 26? Because there are at most 26 alphabet here in English. Okay, so I'm going to make an array. This array is again going to be an array of TrieNode. If you zoom in this value, then you will find that this is again a TrieNode, which is representing A. Okay, so I'm going to make a TrieNode. How to make this? I'm simply making a TrieNode array. The name of this array will be children, because each value in this array is representing the children of the root, right? Okay, so now I have made the array. This is how the TrieNode structure is going to look like. If this is a class, then you can write the constructor as well, which will be a TrieNode, and again this is going to accept some values, and after that it will simply initialize these two values. Okay, now I hope you have understood the structure of TrieNode well. So let's talk about two main function, which is insert and search function. How to insert a value. In order to explain the insertion, I have taken the root, the initial value of root. The initial value of root contains every value as null in the children's array. Okay, and I need to insert this particular string, which is cat. Okay, so I'm going to start with the character C. I need to insert the character C. But if you see here, then this is an array, right? And we need index, like at which index I need to insert this value. So you can see that if I write A, B, C, then 2 is the index of C. But how to get the index of C from here? How to get the index of C? If I write the ASCII value of this, then it will be 67, and if I write the ASCII value of 65, then it will be okay. If I write the ASCII value of A, then it will be 65, which means that A is 65, B is 66, and C is 67. How to get the index from this? I can simply do 67 minus 65, so I'll get 2 here, and 2 is the index of this, which means that I can do C minus A in order to get the index of any alphabet. Here I have C here, but if I write D, then again I will get the same I will get the index of D here. Okay, so I can get the index as C minus A. I need to insert C at this value, right? Okay, but this is not always the case. Let's say we have already inserted C. So is there any need to make a new TrieNode again? Let's say, let me explain. If I have already inserted A here, when I was inserting ADC and I have already inserted A here, then there is no need to insert A again, right? Because if I do so, then I will lost this D value, right? And I will lost this ADB. So I don't need to insert in that case. I only need to insert when the value is null. So I will write if root dot children children of index is equal to null. In that case, I need to insert value, right? So I will make root dot children of index as new TrieNode. It will be new TrieNode here. So this is what I can do. And if I have made the value, if there is a value which is existing, so I need to move to navigate to that value, right? Let me explain. If I'm at this A and I know A is already there, or I have inserted A, then I need to go to that A node, right? And after that we will insert D. So let's do it. Now I am going to move to A. So root will become root dot children of index. If you are someone who is doing this try first time, then you may have some like difficulties in understanding this, but this is pretty easy to understand if you practice this concept a lot, right? Okay, now I need to do this process again and again. So this is going to be a s of I, which is the ith character, and I need to do this iteratively for all the characters. So for I equals to 0 and I smaller than length of str, and after that I plus plus, right? This is what I need to do. Okay, now when the loop is completed, then I need to do one more thing. When I have inserted cat, then I will be at t node, and for this t node I know that the word is ended, right? So I need to do end of word as true. So root dot end of word is now true, okay. So this is the code that we need to write in order to insert any value in a try data structure. I hope you have understood this concept well. Okay, so now this is all about the insert function. Let's talk about the search function now. Okay, so in order to search the value, I have already taken a try data structure which is having string as cat, caps and labs. It is having three string which are inserted. Okay, I need to search for a string which is cats. Okay, so first of all I'm going to search for cat. Okay, C is there. So when C is there, then I need to, initially I'm at root, so when C is there I need to go to that C. Okay, after that I'll search for A. Okay, so what I can do is for each character character in S, I just need to check if C is there. If C is there, then just move to C. Then root will become root dot children of index, right? Index. This is what I need to do. But what is index? Index is again uh, S of I minus A. Okay, now uh, at last, when I'm done with traversing all the values, like C is there, A is there, T is there. Okay, S is not there, but how to like determine whether S is there or not? In order to find that, I just need to check one more condition. If root dot children of index is not there, right, is equal to null. This is how I'm checking, and in that case I need to return false. So let me change the color. I'll return false. Okay, and when the whole loop is completed, then I can surely say that the value is there. Like if you have cat, then I can simply search for cat, and this is null value, right? So this is cat, and I can simply say that return true, right? Cat is there. So this is how the search function will look like. Okay, now I have explained you everything related to try. Like I have explained the introduction to try, after that the try structure, after that how to insert values, and after that how to search for values. So now I'm just going to show you the code. Let me show you the code. Okay, so here I have written the Java, C++ and Python code. So on the left hand side I have the Java code, and right hand side I have the C++ code initially. After that I will show you the Python code. There is nothing more to explain here. Okay, so here you can see that I have made the class TrieNode, which I have already explained you. Okay, so just one more thing is there, which is the constructor value in order to initialize the children array and the end of word. Okay, now I have written the end function, I have written the insert function and the search function, and you can even see here, just the difference is here I'm writing the insert and search function inside the class, and here I have written the outside the class. Okay, so you can see that the search function and the insert function is very similar to the one that I have already explained you. I have the current root here. Okay, after that I have for each value I'm just checking for these conditions. Okay, after that I'm just like moving over all the values in the string, and after that I'm making the end of word as true, and the same thing is written here. Okay, but in searching values, when this condition is true, then instead of making this a new try node, I will return false, that hey, the value is not found now. Okay, so the same thing I have done here. Now let me show you the main logic that we need to perform. In the main logic, if you remember, then you will find that we need to insert the value in the same order as well as in the reverse order, right? So this is how I am inserting in Java, and this is how we insert in C++. Okay, now, okay, so here I have converted into string buffer first, because the string is immutable in Java. Okay, now again I have checked for every condition if the value is found and or the reverse is found. In that case, answer will increase by 1, and at last I need to insert the answer. I need to return the answer, because answer is representing the count here. Okay, what about this solution.py? You can see here that in the Python code, the code is again very similar to the Java and C++ code here. Okay, so this is all about this video. If you like the explanation, then you can hit the like button, share the video and subscribe the channel. This is all about this video. Thank you.